All right, so we're back again. Let's do terrain analysis in QGIS. You go to QGIS raster menu, raster, then you click on analysis. Then you can just choose from here. Okay, so I think the first thing we are choosing is slope. All right, so you want to, it means you want to generate a slope surface. Is that okay? I think we talked about this in one of the last lectures that we did. Okay, so these values will be values that show the rate of change from cell to cell. Is that okay? So let's do that. Let's look at the settings that are available. So you see a few parameters. I think you don't have to do much really. Okay, ratio of vertical units to horizontal. This is called vertical exaggeration. I don't know if you've heard about that word. It's kind of, you can actually change that to have an exaggeration in terms of how the terrain is undulating, okay, vertically as opposed to horizontally, planimetrically. Is okay. So you leave it at 1. Really, it's a factor that if you make it twice, it means like you are really exaggerating more. If you reduce it by half, then less exaggeration. So if you are doing something for like Greater Accra, which is relatively flat, compared to Kumasi, you have to change the vertical exaggeration somehow. Otherwise, you won't be able to appreciate the, the surface or the terrain. Are you okay? All right. So slope expressed as percentage instead of degree. So all these are options that you can choose. Is that okay? Compute edges. Yeah, we don't want to have that. So you leave all this. I mean, that's not it. And just you simply run it. There should be an output. I think always look out for the output. So you see the last thing down here is open output file after running the algorithm. Okay, so that means we will see the output in our QGIS. So click that and then you have a new surface. All right, so in this surface, the slope is in either degrees or is in radians. So you should be able to appreciate the different types of slope. Are you okay? And then know which one that this one applies to. Okay, so 0 is flat. And then as we go up to 68, then obviously we are changing the slope. Why do you think we're having 0 for the black areas? Of course, the black areas are also the areas where we have the, not necessarily, it doesn't have to be the areas where we have the valleys. Because when you look at a particular area like this area, you can see that it's a low area. Okay, it's relatively flat, but it's not necessarily low. Are you okay? Compared with these areas. Are you okay? So these are just visually up, trying to appreciate what happens. Let's go on and look at the next surface. Okay, so this is what we just done. I think we'll do aspects. Yeah, please now. Okay, so we're gonna do aspects. So let's do aspects. Same way, we use the same tools, raster, analysis, then go for aspects. So what is aspects? What is the aspect? So you need to know what it is. Otherwise, you just be playing. It's like a little boy or little girl playing with a toy. You don't have an idea what you're doing, isn't it? All right. So what is a slope? Israel, what is a slope? What is the slope? What is the aspect? Sorry. What is the aspect? At least we know the slope, right? What is, if someone asks you to differentiate between the slope and then the DEM itself, how would you explain that? That's the first one.
So am I explaining the slope?
Yeah, explain how the slope is different from the raster data
The
itself.
aspect.
Not the aspects, just the slope and then the terrain itself. In terms of the values.
Okay.
Mm.
What what a slope is giving the I would say the ratio, the dimensions between the the vertical height and the horizontal heights.
Yeah.
And the dimensions,
So when you compare to the actual, the original raster,
yes.
what values are inside the original raster? What values are inside the slope surface?
Okay, with the slope, we are looking at the one. So if you can come in, I'll be happy. SPG.
Yeah, so obviously the original value terrain, the terrain value, the terrain is a DM. Okay, it contains height values above a certain datum. Is all right. So they could be above mean sea level. So that's the DEM. Okay. The slope values can be in radians, gradients. What's the third one? When you are measuring slopes, what options do we have? Degrees. Are you okay?
Did you say degrees?
So you can have degrees, radians, or gradients. So when you look at this one, it's not radians, 0 to 68. It's not radians, right?
It's degrees.
It could be degrees, right? Yeah, very likely. So in that case, 68 degrees. I mean, what do you think? Is that's the maximum? That means like we're really coming down a steep one, isn't it? All right. Now, what about the aspect? What is the aspect? What values should we have in the aspect? We are about to compute the aspects. What values should we have? So click on the run. Once you got the aspects up there, click on run. So once you click on run, okay, let's see if we can use single band CV color. I'm just changing the colors here. Okay. What just hope? Okay. So it's disappeared with it. Okay. So let's get rid of it. It's looking funny now. Slope DM raster aspects. We want to put in the DM. So the input should be the DM. Is that okay? So run. Okay, so please, the input for the aspect should be the DM. And then we want to also change the symbology, the colors, so that we can have some colorful something. But I think it doesn't really work very well. The software, then again, the software gets, so let's keep it in the, I understand why it's doing that. Yes, because the aspect surface, yeah, I was trying to just change the colors, but I don't think it will work that well because it creates some, you know, some, so it's kind of trying to deceive you to think like you are looking at a surface. And when you change the colors, you won't get the same effect. I think I want to put it like that. So make sure your input is DM and then run it. And then you get this surface. So now here, what surface is this? So the white values are pointing in the north direction. The white values are pointing in the north direction. Is that okay? And then the black values are pointing, well, also, okay, so 0, when you look at the bearings, yeah, there's 0 to 360. So that's where the challenge will be. Between pure black and then pure white, that you need to really kind of distinguish between the two. I mean, seriously, I'm now thinking about that. So let's click on the surface. So these values are actually pointing. So the sun is actually shining from one direction to the other. Are you okay? All right. So we want to just know which direction these surfaces are pointing at. Are you okay? Where are they facing? That's all. That's what the aspect does. Are you okay? We can classify you can do what we call reclassification of this data. I think that is what is interesting. Okay. When you try to group it so that values pointing south are classified in a certain way, then we can, really start doing some analysis with it. Is that okay? All right. How many of you have the processing toolbox in your software? How many do you have the processing toolbox? How many of you have the processing toolbox? How many of you have the processing toolbox? If you have it, just say I have it, because I know someone doesn't have it. Please. Israel, do you have the processing toolbox panel?
No, please.
Okay. Nanaya, do you have it? Taufik?
No, sir, I don't have it.
Okay.
Okay.
I think I've gotten where it is.
You've gotten where it is. Okay, where is it? Where is yours? Can you see processing at the top?
Yes. When you click the toolbox on top of the toolbox,
Yes. If
toolbox on top.
If you have process, I think for me it's in the processing menu. Then you just click processing toolbox. So let's all check if you have it. So you can just do processing.
Where on before the
It depends on your version. So which version are you using? Which version are you using? Okay, don't worry about the version, but where exactly is your toolbox?
Is 3 points.
Go to help and about. You find it there. Mine is 3.16. Anyway, so but you should find it under processing.
You have it. When you I've gotten the processing toolbox.
So do we all have it? I just want to know whether we have it. That's all. Do we have it? If you don't have it, try and get it. Is that okay? So for example, if you want to search for reclassification, just type reclassify. Are you okay? So you can just type recla, RECLA, and then you now click on what you want. You can double click it or single click it. Okay. So then you have, this kind of thing. Yeah. All right. So we can just put in some values here, like 0 to 20.
Put in some values here, like 0.
Add another 20 to 60. So we are 0 to 20 is pointing to northwest. 20 to say, I don't know, 90. Let's just randomly. I just want to give you an idea what we can do with this. 70 to 120. So it's like we're going around the clock, 120 to 200, Please do what I'm doing so that we can all see what you can get somewhere faster. Then we can say above 200, maybe 200 to 360. Okay. If it doesn't work, I know it's because we have 200 being a maximum and being a minimum at the same time. So then we have to find a way to just change that. So 360, yeah. So let's just do this and see if, it can reclassify and give us a new, table. That would be like interesting, isn't it? Okay, so invalid value for table, list must contain a multiple of 3 elements, found one. Okay, so let's just see if, I think these values need to, they don't have to repeat it. Let's do 21. Let's see. Oh, of course. So now we have to give it the new values, isn't it? So 0 to 20, we want to call it, we'll give it a value of 1, 2, 3, 4, 5. Okay, to make it more, I don't know, for some reason, 20, 30, 40, 50. Okay. Right, okay. Okay, 2. Okay, so yeah, we're getting a few errors, but yeah, that's the idea. We just need to get rid of the errors. Which one is this one? Let's see. I'll go ahead and reclassify by table. So then the latest command is this one. Okay, let's see. Invalid value for table. The list must contain a multiple of 3 elements. Found one. What is this one? Okay, loading resulting layers. I'll go ahead and reclassify table. Finished. Where did it go? Okay. Okay, so let me see if I can clear the log. Okay, and then probably run it again. Okay, so this is the error that we really have. What does it mean by this? Okay, valid value for table. A list must contain a multiple of 3 elements. The list, 3 elements, but we're getting, what are we reclassifying? Okay, classify table. All right, okay.
So let's be adding 0, 0
0 to what?
to the figures, and let's run it.
What is the justification for that? Adding zeros.
Because of the error that is given to us, multiply
So,
by
but do you
3
understand the error?
elements. I'm just suggesting. So.
But your suggestion has to be justified, isn't it? No data formation. Okay. The last around this, but I think probably I'll look at it. Maybe the next time that we actually do this class. It's simply because the software is not very usable, but obviously we want to understand how it works. It works. I know it works.
So, well, I think what my colleague was saying might be true.
What is she saying?
With the 3 element B, let's see 0, 0, 0. So 20 could have been 0, 2, 0.
But okay, anyway, I don't think that is the reason why it's doing that. 0, I don't think so. That's not the way it's supposed to work. 3, 0, 3, 15, 5. Okay, so it worked, but I don't think it's a 0, 0 that caused it. It's rather the okay we put in there. Let's see. Let me remove the 0, 0 to see. Okay. You see, that one also works, right? So I think we didn't click OK. I think that's the main thing. But this is what we want to see, something like this. So here we've done a classification. When you look at this one, it means that all values that are pointing in a certain direction, 20 degrees, 30 degrees bearing, yeah, 20 degrees of bearing to 30 degrees of bearing. Those values have been classified separately from, other values between 30 and then 350. That's what we are actually looking at here. So you take the information to, okay, here we get 5. So there are 2 classes here. All right, we just have 2 classes in this particular scenario. Are you okay? We have 3 and then 5. So when I click on the black areas, I get 5. We can look at on the right hand side. And then when you actually go to the white areas, all right, then we should get something else. Okay, this is 5. That's 353. Band 1, 354. Okay, let's look at this one. Okay, so let's turn off all these. Let's make this layer active. Okay, this one, 354. So it will be 35. So these values are actually varying a little bit, which is actually quite strange. But the idea is that I can see visibly, we can all see that there are 2 classes, as opposed to the original data, which is this one. Okay. Okay. All right. So if we actually choose the values properly, then we'll have as many classes as we want. Okay. But for the original, when we look at the original data, let's look at that. Okay. The original data has a lot of values. Are you okay? It has a lot of values. I'm expecting to see the actual classes also in there, but yeah, we seem to still have like a bunch of values for the classified values, and there could be, it's from the parameters. When you go to reclassify again, the way you set the table will determine, the kind of values that you get. Are you okay? So you may end up capturing values that you don't really want to capture. Are you okay? Or have a range of values in there based on the way you do the classification. So the final result depends on the inputs. All right. So Israel, this is one of the fundamental things that you will do. And then later on, what you can do is that you can combine this with other values. For example, there's the 5 that we put in there, or the new values that we set can become factors. So let's say that, okay, you create different surfaces. Are you okay? For drainages, are you okay? And you say, okay, I'm buffering the drainages. I'm actually, I'm buffering them, and then I want to rasterize it. Are you okay? So you can do what we call rasterization. And I think that is what we want to do in our next lecture. Okay, but for now, let's look at the road data. So I believe we appreciate what to go into classification. What we just did was to just see if the software really works. Let me just say that. But the values that we put in there, we didn't even think about it. We wanted to see if it works. All right. So this is it's supposed to be like 2 classes, but I think there are more classes than that. If you have just 2 classes, you get 2 colors, and there shouldn't be any values in between. Okay, reclassified raster 5 should be here. Okay, you should be having 353 in there, because I don't remember we assigned that as a new value. But the black area, so I see 3 here. Okay, I see 3, I see 5. Okay, so we need to really look at the classification. Okay. So when you even look closer, you'll be seeing different pixels. That's 17. Right, so we need to.
Can I ask a
Yes.
question?
Yeah, go ahead.
Yeah, please. What is the idea behind of all these things?
The idea behind this, were you in the last lecture where we talked about surfaces?
Yes, I remember that. Yeah.
Okay, what did we say surfaces are? What are surfaces?
What I'm expecting from this, that maybe where you can apply this thing, it will
What
be
the question
applicable.
is that what are surfaces? What are surfaces?
I have to read over again, but
Okay, very good. So that's where the challenge is. Yes, sir. So your question is not appropriate because you don't know what a surface is. So everything I'm talking about today, in terms of the practical, what we have done is we are looking at a surface, how it is represented, and then how it can be manipulated. All that has been talked about in a lecture, which you probably didn't understand. Are you okay? So that is where the challenge is. Sometimes you can't follow something if you've missed a particular topic. I have to now keep that lecture again. So you go and look at the video on surfaces. Is that okay? Where I talked about the essence of what you are looking at right now is there. Are you okay? Uh-huh. So please look at it. In a particular lecture, you see me drawing lines like this. Hmm? That is what you are now looking at like that. So they are actually lines. These are pixels. Yeah, they are pixels you are looking at now. Hmm. Based on the resolution of the data. So we can talk about resolution. So all this have been talked about in previous lectures. The whole idea was preparing you for this. Mm. Please go and watch the video. When I go, I see that two views. For some of the videos I put out, there are two views. The whole idea is that you can watch it so many times, or probably download it and watch it over again. It's all right. Or maybe Israel can explain it to you. Israel, if he'll be nice to you anyway, but Israel, I won't let you do that. So please don't miss the lectures. Don't miss the lectures. All right. So basically that's that. Let's look at the raw data sets. Let's remove everything. Let's create a new project altogether. I'm not going to save. Okay. So let's drag our raw data into it. It's actually a vector data set. So let's open our folder, our data folder, and we find some rows in there. So then again, so many files. Some of them are not necessary. Some of the files there are not necessary, but those that are important are the ones that we need. So I'm showing you the folder. One of the things that you don't need is a QIX. Okay, QIS is got something to do with QGIS. Okay, maybe it was saved somewhere. So even if you delete it, it will affect it. This is the so-called, this is the shift file, not so-called. This is the shift file. I've deleted two files, which we have learned in class don't belong to the shift file. So if I delete it, I'm safe. But the rest, .dbf, .plj, .sbn, sbx, all these are part of the shift file. Now this file is not the shift file, the file that we need, the core file that we need, the shp. It's actually an XML document. So when you look on the right hand side, you see XML. Type XML document. Then we have rows. You see AutoCAD shape file. That's what we need in GIS. The sisters, these are the family members. They need to go along with it. You know, I mean, so that you understand. I'm using the phrase family member. These are the family. You know, these are a group of files that work together with this one. Okay, they accompany it. So you drag it into QGIS, and then you begin to see some lines. Obviously, the lines represent roads. In fact, road center lines, ideally. Because if you come, there's no need to really store, show the edges of roads. It's not necessary. Why? Because it can always be generated, okay? Or we can use a symbol which can just depict the road, okay? So we are not doing art here. We are doing, okay, modeling. We are modeling the real world, okay? All right, so you can zoom to it. You can use the information tool and then click, and then you get to know that we have the one I just clicked right now, click it, is the Olympics road. So you can see that these are the attributes, yeah? I mentioned attributes in class. If you took notice of it and it showed any interest, this is a time for you to see the attributes for yourself. These are the attributes I've been talking about. Okay, so the attribute values are on the right, and then the actual attributes names are on the left. Okay, so this is the metro at Accra Metro. I think so, AC. But it could be anything. Link number 007, road class D. This is road class D. So this small thing highlighted in, yeah, this small segment of a road highlighted have so many what attributes. Okay, the main challenge for transportation is whether this data set is actually suitable for, network analysis, which is where we try to find the shortest route, isn't it? All right, so you need to now start thinking about the length of the road for network analysis. You need to also look at whether the data set is actually like topologically correct. Topologically correct. Is that okay? So let's go into our toolbox and type topology. Okay, I see topological coloring, but I'm not really interested in that. Let's go to vector. Topology checker is right on top of the vector menu. All right, so let's click that. And then we have the current layer, which is the rows layer selected. All right. One of the first things you want to do if you want to check topology is to configure it. You just don't run it. So you don't validate. Why we validate? Because topology has got to do errors, isn't it? So validation, remember. So you have to now set rules. Okay. So look at some of the interesting rules we have here. So the current rules apply to the road layer. So road layer endpoints must be covered by, there's no other layer to compare. So sometimes you do the topology against another layer, which is very good. It must not have dangles. Let's start with that one. And we all know what dangles are. I think I talked about it. When you have a dangle, yeah, in GIS, then it means that it kind of, it's a loose end. Are you okay? Networks are supposed to be connecting. So let's try this and see. This is just for your, so I believe you're all doing what I'm doing. Yeah. Okay. All right. So that is my setting. So I have one rule. Okay. So I can add another rule. I can pick the root and then add another rule. I can say must not have duplicate, must not have pseudos. Pseudos are like false geometries. Duplicates. Let's add must not have duplicates. So we can have more rules added to it. Is that okay? All right. Let's just take these two rules and then we are just going to click on validate. So we have validate and then we have validate the extent. So we can decide to just do the view. So the extent is what we are looking at. Okay, so let's just try, validate the extent, not validate everything, and then see what happens. So now you can see that these are dangles. The red dots are dangles. Yeah, they're like dead ends. Are you okay? They can be errors because normally you don't have roots just hanging like that. As part of it, in a network, you always want to have a connection. Yeah, but obviously we all know that depending on the built up area, the way it is, this could be just okay. All right, so this is one of the basic things you can do, and then you can correct. So you can edit the layer, all right, by just going to click that start editing. Is okay, and then you can pick an editing tool. And then there you go. You can just be moving things around. Are you okay? But you have to be careful. You should know what you're on about. If you're not sure, just get out of it. Otherwise, once you're ready, you can just introduce new segments. Are you okay? That's a new life. Okay, we can just introduce a new one. Okay, and then add attributes to it. Is that okay? Please, are you doing what I'm doing? All right, I hope you are. Okay, so basically that's that. Topological errors can help us to correct the data and make it good. All right, what are things we can do? We can snap. Yeah, if it's not really snapping, we can set a snapping tolerance for it, and then it'll be just good to go. All right, we can delete some vertices if you want to. All right, so the delete button is there. All right, So apart from just using the information tool, one of the things we can do is that we can actually select, so where's our selection tool? It should be somewhere that we can easily pick up. Okay, so this is just a browsing. Okay. It's gone hiding, isn't it? Okay. But obviously, I'm selecting this row, isn't it? So it serves a purpose. This one is selected. We can open the attribute table and then look at the particular, you can show features that are being selected. So apparently, we are only highlighting the, because we don't see it in there. So it means it's not really selected. And the selection is gone hiding. All right. Should find it somewhere. Select features. Okay, so there it is. It's down here, this one. So if you select this, we can now go to the attribute table and see it highlighted in the attribute table. Okay, so we selected just one thing. We can select more, probably press shift or control. We have two things selected. So you can see now I have two records. Okay, so these are basic things we can do in QGIS. It depends on what you are doing. Yeah. All right. In terms of network analysis, we can look for shortest path. So shortest path, we have several options. So we have layer to point, point to layer. I mean, seriously speaking, you just have to play around with it. Someone's program they've written, so it's not rocket science. Okay. So where you see the parameters required are not available to you, can choose a different option. And then you see what happens with the shortest path. So vector layer with start points, we don't have that. Okay. So that's, we need to try, choose a different one. Point to point, let's try that. Start points. So we want to find the shortest path from here. I guess there should be an endpoint to, let's choose another point. Okay, run it. Okay, so we have the shortest path done. Okay. So we can zoom in and then